Okay, so now that we have installed R and RStudio, we are going to learn a little bit about how to use RStudio to write code in R for data analysis. So for the assignment, you were instructed to download a folder from the class GitHub repo called Intro to R. So I have that folder right here. So go ahead and just get that onto your desktop in a place where you can find it. And there's a file here called intro to R .rmd. And RMD is a kind of markdown file in which we're going to combine text and code to produce a nice little data notebook for analysis. So the first thing we're going to do is go ahead and just double click this file to open it up. And this will open RStudio, and the file will open up inside of RStudio. So I just want to walk you through a couple things about what we're going to learn in this lab, and then we'll keep going. So this is what's called an R Markdown document, and you're going to work through this document throughout the course of this lab. And it's designed to serve as an introduction to not only the R programming language, which we installed, but also the RStudio integrated development environment, or IDE, which is kind of a special software tool that combines a text editor, a little command line console, and some other features that make it really easy to write R code. We're going to learn a little bit about the purpose of using these R Markdown files. This is an R Markdown file for doing reproducible, documentable, fact-checkable data analysis. We're also going to learn a bit about a package of code called the Tidyverse, which is sort of like a framework. These really great people who made it their mission to help people do data analysis produce these really nice suites of software packages that we're going to make use of to write code. And then we're also going to be working with data on opioid shipments in the US, which we've been working with all semester. So my advice would be to follow along with this video. Read this document carefully as you're going through it. In most cases for this assignment, you're going to be asked to simply run pre-written lines of code that I have created. But there are some places, and they're identified with 2 asterisks, tasks, you'll note that turns blue in this document, in which I'm going to ask you to write some code based on something I've written, or modify some existing code. Okay, so let's start with about R. So R is a programming language that is very helpful for data programming. It's used by data scientists and data journalists, people in all sorts of fields, from science to health and medicine to business, use R. One of the reasons I really like this as a language, that there is a huge community of users, other people, who just seem to be really cool about wanting to help other people learn how to do it. There are many other languages we could be using for this. A lot of people do data journalism also write a lot of what's called Python or SQL. I use those 3 languages all the time. But I've found, especially for people who are trying to begin working with data programming, the approachability of the community of people in R is just a real selling point. And so I can't recommend it enough, and that's why I teach it. If you want to learn a little bit about more about R as the language, just pull up R project here. Has some information about it. There's also, like on Twitter, the RStats hashtag. You'll find a ton of people who are writing about cool things they discovered or made. This guy Hadley Wickham is the father of this Tidyverse thing that we're going to be using. He's really cool. Definitely give him a follow. Yeah, so lots of people talking about it, wanting to help others, lots of good tutorials, which is a big reason we use it. I've already showed how to download it in an earlier video, and if you're running this, you probably have found it, but this is where you where you can download it for Mac. Okay, so RStudio is what's called an integrated development environment that is designed to help you do data analysis. If everything has gone right, you're actually looking at this R Markdown file inside of RStudio as we speak. So in general, the way RStudio works is that we've got a space like a text editor. This is where we're going to write code. There's a console. This is like the place where the code actually runs. And then over here, we'll see there's like a browser directory, like a place to go look for and find files. So this is this file we're looking at now. Once we start loading some data, you'll see our data pops up here. And we can also look at data, much like a spreadsheet viewer. There's some great guides for this. So there's the RStudio cheat sheets, and I'll just pull that up here real quick. I just clicked on that link. This is like a little bit of a guide, like we'll walk you through how to use it. RStudio also up on their website has just some information about it, and you can watch this little video to take a tour of what it does. But it's
all the data you currently have loaded.
It's really a useful tool, and I can't recommend it enough. So you can watch that on your own. And if you're looking inside here, this is where you can go download it. But if you watch the earlier video from the class, you will already have had this downloaded. Okay, so R Markdown. There's lots of different kinds of text files. A lot of people write R script inside of a file with the extension .r. R Markdown is kind of this cool, allows for like some interactivity, and it allows you to combine code and text and links and the output of your code into sort of one package. And actually there's a nice way, we'll see at the end, to turn that into an HTML file so that you can look at it. Markdown, R Markdown is a sort of special flavor of Markdown, which is a method or a technique for making or styling text so it looks nice. In the same way that like the HTML, the markup language, HTML, hypertext markup language, Markdown is just like a little bit easier to write. I'll just show you here real quick. So the syllabus for our class is actually an MD or Markdown file. And you'll notice there are like some, there's this big header for data journalism, and then some normal text. And this is a list, which is something you can also do in HTML. This text is bold. There's some links, right? So this is sort of more than a normal text file. This is actually what that Markdown file looks like under the hood. You'll notice that this is really big, right? Data journalism has a hashtag or pound next to it. Course syllabus is like slightly smaller than this. It's got 2 pounds next to it. These list items here have asterisks next to them. This is marked up or styled text. So that's kind of what we're going to be working in as we work through this environment. But R Markdown is sort of a special kind of thing, right? So we're going to use it as our data notebook, and it's going to allow us to integrate styled text with our code and the output of that code, and it will allow us to combine, like in a really transparent way, where we got the data from, what we did to clean the data, what questions we asked of it, what the output of those questions were, and what those answers were in the code. And then when we go to publish, we can turn it into a nice like HTML document. We could like link to it from a story that we've written that's founded on data analysis, that allows us to transparently show how we arrived at our conclusions. I just want to show you one example of what a finished one of these looks like. So this is a project that the Howard Center for Investigative Journalism, where I work, did in partnership with Capital News Service at the University of Maryland and NPR on climate change-driven temperature increases. So this is a nice little HTML page that I and some students worked on that combines like text and links and explains like, here's all the work we did, here's links to like a lot of the supporting documentation, here's code we wrote, and then we use this as a sort of a line-by-line fact check. So here's a line that appeared in an audio story that appeared on All Things Considered. Here's our explanation for the analysis we did that backed that up. Here's the code that we wrote and the output that supports that. So that's the kind of thing we're going to learn in this class. A lot of what we want to do with our data journalism work is be reproducible and allow other people to fact check it and look at our work. And that's what these R Markdown notebooks allow. So in R Markdown, we write text just like we normally would. We create headings by putting like hashtags in front of them. We create links by, in this format, which is the text of the link is inside of brackets, and then there's a parentheses and a link, the HTTP link links out inside of parentheses. But then we put code actually inside of these little code blocks. So I've got an example of one below. So these code blocks start with 3 tick marks, and if you're looking for the tick mark, it's in the all the way upper corner of the upper left corner of your keyboard. It's not an apostrophe. So 3 tick marks, and then 2 curly braces with the letter R, saying, indicating to the file, hey, we're about to write some R code. So that's the start of this block. The end of this block, we do 3 tick marks again, and that marks at its end. Notice that RStudio sort of changes colors. It helps you. It turns the background here gray so that we know that that this is a place where R code is going to run. Okay, so we're just going to write our first little chunk of R here. You're actually not even going to write anything. I just want you to follow along and sort of do what I do. So there's this little play button here in the upper right corner of this block, and this is basically a sign that's like, what it means is like run the code that's inside of this block. So in this case, right here we have a comment. So this is a comment. Comments start in R with a hash or a pound sign. As long as we have this thing to indicate that they're a comment, they aren't actually executed when we run it. So when I press this green button to run the code, R knows to ignore the comments. So this is your first little bit of R here. So this is a function. A function is simply something that takes an input and produces an output. So like when you calculate the average on a list of numbers, that's a function. And we did something like that inside of Google Sheets earlier. Or when you convert a temperature from Celsius to Fahrenheit, that's a function. In this case, this function says print or reproduce whatever I've put inside of the parentheses here, and what goes inside the parentheses is often called an argument. Reproduce that inside of the console. So when I hit that play button, it prints, I am writing R inside of the console. Just note here, when we're working in R Markdown files, the actual console, the place where all this code runs, gets hidden. But I can just click this button down here to pop it open. And you'll notice when I hit the play button, it actually runs down here in the console. So I am writing R. We could write code directly in the console. I mean, I can write that same thing. So print, and then I am writing R. Hit return, and it runs. You're welcome to do that. What I would say is that it's much, much better practice to write your code in script files and run it from within there, so you have a record of it. It's okay to like try stuff out in the console, but the whole point of working like this is that we have a reproducible thing at the end that we can show somebody else and ask them to fact check our work or prove that the conclusions we came to were accurate and true. Okay, so just a couple things about this block. So I just want to show you, if I delete this first line here. Notice it all turns white. So now it no longer is a code block. Okay. Notice the green play button is here. If I have a space between the 3 ticks and then the R inside of curly braces, sometimes the play button goes away. I don't know if it's going to happen here. Maybe this bug has been fixed. But yeah, it used to not always show up. You can also run bits of code. So there are other places to run. You don't have to use these sort of green things. I can also highlight this and go up to this drop-down menu, and I can run just the line that's highlighted, like so. Or if my cursor is just sitting in the middle of that line, I can run that selected line again. I can run the entire document at once, and that's actually something that you'll see us doing quite a bit of. Once we get things in shape, we get our document just as we want, order by order, and then we run the whole thing at once to produce a nice output file. Okay, so we've come to our first task. So what I'm going to want you to do is to write some code here. So you're going to create a new code block below this paragraph. So right here, and you're going to put in a comment inside that code block that says, I am printing out my name. That is to say you are going to write something that just tells us what it's going to do, but not actually print out like in the console. And then I'm going to want you to write a print function that prints out your name and executes it. So let's go ahead and do this first task together. In the future, I'm not going to show them to you. You're just going to see them. So 3 tick marks and an R. And then I'm going to be sure to close it at the end with 3 tick marks. I'm going to put in a comment, starts with a £, that says, I am printing out my name. Why do we do this? Why do we use comments? We liberally comment our code because, one, if other people are looking at it, we want them to be able to understand it. One of the ways in which you will all find is that you will learn quite frequently by finding examples of code people put on the web. And it's really, really important that the comments you'll find the comments are in those spots because it just makes it easy to understand what somebody's trying to do. So partly we're paying it forward. Maybe in the future, somebody will come across your code and that will help them. We're trying to be good stewards of this community. The second thing is that you're trying to help future you. So if you are doing data journalism, you may be jumping in and out of project. You may work on something for a month and then come back to it 5 months later. You're helping yourself out in the future if you know exactly what you were trying to do in a given situation. And the third is for somebody else who might come along and need to fact check your work. You want to make sure that your assumptions are their assumptions when you are having them reproduce your work. Okay, so we're going to write a print function. So I'm just going to write print, and then notice in RStudio too, it does these cool helper things, which is examples of different functions that you can work in. Print, and see how this says base? This means this is part of the base R language. We'll talk more about packages in a minute, but this is a core function of R, as in you, right out of the box, without adding any extra sort of code, you can use these functions. So print, super basic. So print functions usually in R have a paren like that, and I'm just going to print out, well, you're going to print your name, but I'm going to print my name, so Sean. All right, and then we're going to run it. There you go. So when you see task, that's what I'm asking you to do generally. Create a new code block and then do what the directions say. Okay, so let's keep moving down here. So I want to talk about R project files. So as the semester goes on, we'll talk a lot more about sort of how to organize your projects so that you can keep everything nice and tidy and everything works. A key part of that is using something called an R project, or setting up an R project for each one. So R projects have a file extension of rproj. So in this folder here, right, we've got 3 files. This R history thing that it was created when we started working here. It's just a way of tracking what we've been working on. This intro to R.R markdown file, which we are using right now. And then in this data folder, there's some data that we're going to use later in the exercise. So what I want to do is create an R project, and I'll go through that in a second about sort of what the point of it is and why they're useful. But let's go ahead and create one first. So actually not sure if you're going to be able to see this on the video, but I'm going up to File, and then here where it says New Project. So File, in the File menu, New Project. And we are working with a pre-existing directory here. Often when you're sort of creating your own, you may want to, there may be reason to start a new directory. Typically though, the workflow we're going to show in this class is going to be you're working with a directory you've already created. So we're going to associate it with an existing directory, and I'm just going to browse and find it. So in this case, it is this intro to R folder. You want to make sure it's at the what's called the root level of the project you're working in, and I'm going to click open, and then I am going to click create project. Okay, just going to reload that, and now we have this intro to rproj file here. Why are these things useful? Well, there's a bunch of reasons, but probably the most important reason for using an R project file is that it does what's called setting the working directory, so that when we go to load data or refer to other files, we don't get a bunch of errors. So this intro to rproj being here means that when we go to load in the data that's in this folder, it will just happen smoothly. Okay, so you have another task here. This is your second task. Just go ahead and create an R project file and save it in this folder, and it should reopen back up. So if you want, pause the video while you go about doing that. Okay, so now we are going to talk a little bit about R packages. So R packages are pre-written bundles of code that provide shortcuts or make it easier to help you do all kinds of things in the data programming universe. These are things like visualizing data, cleaning it, scraping data from websites, pulling down data automatically from Twitter. There are thousands and thousands of free packages available for your use. We're going to talk a lot about one in a minute called the Tidyverse framework of packages. But just know there are tons and tons out there. So I'm just going to click on this link here in the R. And by the way, I'm holding down Command and clicking inside of this R Markdown file to open it up. If I click on this link, packages here, there are like 15,000 packages. And I'm telling you, there are very specific things. So things for medical use, pan-cancer variable selection, things for doing very specific kinds of regression analysis. No idea what this one does, but it allows you to track animals. Depending on the project you're working on, connecting to SQL databases, you may find a package that's very, very useful. I found one for a project I was working on this summer that did a lot of great things for calculating heat index values. I've worked a lot with geospatial libraries. There are so many great things that people have done. Yeah. So there's also this link of like some really cool packages that are worth looking at. I kind of like this. It's like a curated list of some great ones. So like a package that makes it easy to teach R, packages that allow you to write Python inside of R. Yeah, just a ton of really great stuff. Okay, so most of this class will be taught using one collection of packages called the tidyverse. And the tidyverse is actually not like a single package, but it is a collection of packages that make doing data cleaning, data wrangling, analysis, and visualization easier. It is possible to do pretty much everything we're going to do in this class without using the tidyverse, using just the base R language. What I will say is that will generally take you a lot longer and be a lot harder to understand. My general advice to you is try and think about doing data analysis in the tidyverse framework instead of just doing it in sort of regular R. In general, easier to understand. So let's just take a look at this real quick. So here's the site for the tidyverse. It's a collection of different packages. So there's a package called ggplot2 that's all about data visualization. There is a package called dplyr that is all about sort of manipulating and analyzing data. There's a function here called group by and summarize that are, when we get to it, it's going to feel a lot like doing pivot tables inside of Google Sheets. Reader is a package that we're going to make use of very shortly. That's all about loading in data. It makes it really easy to load in data, including the opioid data we're going to be with. Purr, this adorable cat, is all about writing functions inside R. We'll eventually get to that a little bit later on. There are a bunch more. Stringer makes it easy to work with text strings. Those are part of the core tidyverse package, but then there's also like Lubridate that we're going to use that makes it easy to install dates and times, work with date and time data. So tidyverse, super useful. Whenever I'm searching for how to do stuff, generally I'll throw in like how to do this in tidyverse or dplyr or reader, because I'm looking for a solution generally that uses those package. For a lot of the tidyverse packages too, there are these really helpful cheat sheets, and I'll often be linking to them and referring to them. So just for example, I was just referring to the reader sheet, right? So I'll just go ahead and open that up real quick. So this cheat sheet contains all kinds of information about if you want to get really specialized about how you're bringing in data. This will be helpful. You can also search on Stack Overflow. You can also search on Google. All kinds of ways to get help with these things. And there's also a help function built into RStudio, which we'll go over. There's also a really great book called R for Data Science that was written by that Hadley Wickham fellow I mentioned earlier. He's from New Zealand, so a lot of the spelling and stuff in here will be like, British. This book uses a lot of the sort of tidyverse framework and tidyverse functions. So if you're looking for help, this is a really useful thing too. And then I'll also be recommending some courses that we'll be taking or will be optional. So we'll talk in a minute about how to load that package. The data we're going to be working with for this is the same data set that we have been working with all semester, which is a small subset of the DEA's ARCOS database, which documented shipments of 76 billion opioid pills between 2006 and 2012. during the peak of the opioid epidemic. We'll be working with a subset of shipments that were just sent to Mingo County, West Virginia, which was a county that was particularly flooded with hydrocodone and oxycodone during that period. It received more pills per capita than all but a handful of other counties in the U.S. I got this data thanks to the benevolence of a lawsuit filed by the Washington Post and the Charleston Gazette-Mail. They filed a lawsuit to get this data, which was kept private for years, and then released it in slices and chunks for other journalists and other people to work through up on their website. So what we're going to be working with is there's some aggregate data, right, from Mingo County, but this is sort of the data in its more raw form, which is one record of a transaction or a shipment of opioid pills from a manufacturer to a distributor to a pharmacy. And this is, the thing we've been using kind of all semester. For a data dictionary, it's not a one-to-one match with the data in the version we're using. Some of the column names are slightly different. But this ARCOS Registrant Handbook has information about how to interpret the fields and some of the values in the fields. Okay, so I want to take just a second to talk about process here. So generally speaking, each time we're working with a new data set, we're going to create a new project. Every data journalist has their own sort of method for this. In general, here's what we're going to follow in this class. We're going to create a new GitHub repository for our project with a README file explaining, where we got the data and what we're hoping to do, key terms, links to data dictionaries, a gitignore file, which will allow us to, store or prevent us from hitting GitHub's file size limits. So we'll set up a new repo. We'll clone the repo folder to our desktop. We're not going to do that today. If those terms are like Greek to you, do not worry about it right now. Just know that in the future, that's something we're going to do. Today, all you did was you just downloaded this file I gave you in your desktop, and that's what we're working from. So inside of that folder, in the future it'll be a GitHub repo, but right now it's just a folder. We will create a new R project, which is something you've already done. We're going to create a folder inside of that where we're going to store our data. And then we'll create a new R Markdown file, and that's what we're going to be working with. So it's kind of what we have here, right? You can see this over in the file browser. We've got an R project, an R Markdown file, our data, and then this R history thing is created. So after that's done, generally what we're going to do is work through the following steps. We're going to write a little introduction at the top of our R Markdown file with information about what we're trying to do and where the data is from and that sort of thing. Then we're going to write some functions to load the R packages we need to work with. So today, the only packages we're going to be loading are the Tidyverse suite of packages. In the future, we will probably load others depending on what we're working on. Then we're going to write some code to load in the data. Then there'll be a process of exploration where we'll get a sense of what's in it, what the rows and columns are, what flaws might exist that might prevent us from analyzing the data, or even worse, producing inaccurate results. We might do a lot of this just by looking at it, but this process, generally speaking, in the real world is informed by talking to sources, reading documentation, reading research papers, interviewing experts who have worked with it. It's more than just looking at the data. There is reporting involved as well. There'll also be a cleaning step where we clean the data by correcting flaws we've identified. So maybe when we uploaded the data, it was stored, all the numbers were stored as characters or text by accident, and it means we want to do some math on some of the columns, but we can't, so we might fix a problem like that. Maybe there there's a bunch of missing values that we're not sure what they mean, and we need to understand what that means. Generally speaking, there's sort of often an initial cleaning step. We're actually not going to do that today. We're going to get right to the fun stuff, the analysis, and we're going to talk more about that during the semester. But just know that that's a critical part. Next, we're going to, today we're going to learn about sort of different things that we've done in Google Sheets, some of the techniques. But generally speaking, the process that we'll have is we'll have some questions that we want to ask, and we'll start, quote unquote, interviewing the data. So the questions that we develop will be informed by our own intuition. Often we had a reason or a question we wanted to answer that spurred us to get the data in the first place. So in this case, our question might be, what was the pharmacy that had received the largest number of opioid pills in Mingo County? There are some standard questions we might ask of any sort of data set. We might try and learn what the minimum and maximum values for shipments are for each pharmacy. We're also gonna, the best questions come about when we're actually talking to people who understand the data we're working with. Contextual reporting that will just allow us to ask better questions. And that's a critical step. We should know that data analysis does not happen in a vacuum. To develop interesting questions, you really have to do research and reporting. Okay, so we'll probably do some initial analysis. We'll have those findings and we'll output them. And then we'll do some follow-up reporting based on the results of our analysis. We might find ways to sort of humanize the trends we've identified. We might report out specific things we find in the data. Maybe something just seems like incredible or unbelievable even. And we might do some fact checking or smell testing with experts to say, look, I got this result. Does this seem right? We'll also talk with experts who have worked with this data or experts in statistical analysis, especially if we're doing something more complex, to make sure our analysis is credible, fair, true, correct. Eventually, we'll take kind of everything we've done. Our files may be a little kind of messy. And generally what I'll do is clean up the Markdown file. So it really only contains the sort of necessary things that are used in the story that I plan to publish, the foundational stuff. And this would be the results of loading and cleaning and analysis. I may save a lot of the code that I've written that doesn't lead to things that are going to be published in a separate file. But generally speaking, what I'm looking to do is produce a documental, a sheet that contains all of the results of my code. Then I'm going to hand it off to somebody else and ask them to look over my results, try and reproduce them, maybe try and generate them from scratch, taking different approaches, bringing what they know about data and data analysis and the subject to make sure I'm not totally screwing something up. Okay, so just one thing to say too, I've written these steps out linearly. We load the packages, we load the data, we get a sense of it, we clean it, we interview it, we do reporting. In truth, this process is often very nonlinear. Things loop back on themselves. So like I may want to get all of my data cleaning done sort of near the beginning, but maybe I don't identify a problem until I ask a question in a specific way during the analysis process, which forces me then to go back and like clean up the data before I can move on. Or when I am finish my analysis and I'm going out just to double check things with experts, they may say, oh yeah, the reason you got that is because you failed to consider this, and really that's a meaningless result, so maybe you want to rerun it. So I'll go back to the analysis stage. Or sometimes we'll talk a lot in this class going forward about joining data sets together to develop new information. That's where a lot of the best journalism kind of happens, taking two unrelated things and linking them together. I may talk to an expert and say, have you considered like using this data set to adjust for it, which will require me to go out and get that data and load it and clean it. So All of that will sort of play into the process. Or even worse, but this is why it's there, a colleague may uncover an error during the fact check process, which requires me to redo analysis and maybe go back to the drawing board in some cases. So that's a big part of it. Okay, so let's get started. That's most of the qualitative stuff out of the way. So I want to go through the sort of steps, right? So normally when I am coming into doing a new bit of analysis, we've created a new Git repo, we've created a markdown file, we've created an R project, I've got my data. One of the first things I want to do is to load the packages I'm going to be working with. So in this case, we're going to be working just today with the Tidyverse suite of packages. So I want to install Tidyverse. The function we're going to use here is called library. And when we run this, what library does, it says, if we've installed this Tidyverse package, downloaded to our machine, unpacked it, then let's just make it available for use. So I'm just going to go ahead and hit play here. And I want you to see what happens. Okay. So first thing it did was it installed it. I already had it installed, but the reason I put this here is that I imagine that most of you will not have had this installed because it's the first time you're using it. So if it's the first time you're using it, you're going to have to install it. And the function for that is install.packages, and then in quotes inside of the parentheses, Tidyverse. All right. Then to load it, to make sure it's available for our use, we use the library function. So if you're working on the same machine, you will only ever have to install this Tidyverse package once, but you'll have to load it at the beginning of every session you want to use it in. So I'm going to hit play, and this time it didn't spit out that install stuff because I commented out, quote unquote, commented out by putting a £sign here, or a hashtag. Note that when you install packages, it needs to be in quotes. When you load it with library, it doesn't. I'm not sure why that is. It's just the way it is. Okay, so if I hadn't done that, a lot of the other functions we're going to use, including the one that we're going to use to read in the data any second here, would not work, and we would get an error. Okay, so now we can't really do any data analysis unless we have some data. So the next thing we're going to do is actually we're going to load up the data we're going to be working with, which is the opioid data from Mingo County, West Virginia. So this code block here contains the information, the code that's going to allow us to read in this data so that we can work on it. So the function we're going to be using is called read_TSV. TSV stands for tab separated value. It's a kind of text file. I can actually pull that up so you can see it. Nope, it's too large. We can't do it, but it's a file in which it's like a spreadsheet, but the columns are all separated by tabs, which are kind of invisible characters typically. There's also another function called read CSV, so CSV, which stands for comma separated values. So this is part of the reader package, which is part of Tidyverse, and the reader package was made available when we loaded Tidyverse. So here's a little guide to how to do it. This is information about how to use the functions. I look at this documentation all the time. I've been writing R for many years now, but I find these guides invaluable. You can't store everything in your head, so it's good to come back and be able to see specifically how to use a given function. Okay, so I'm just going to press the play button and load it in here, and then I want to break down what happened here. Okay, so inside of the TSV function, I've got the path to the data. So this file, intro to r.markdown, is in this folder. So what this says is go into a folder called data, find a file called Arcos WV Mingo 54059 itemized.tsv. Woo! There's that file. It's a 16 meg text file. So it says, find this file, read it in. So in Google Sheets, there was a button we clicked where we uploaded. We're not doing that here. We're writing a function to do it. And what it's saying, this little arrow key here is saying, take the results of this, uploading this, and store it as an object called Mingo. This could be anything. It doesn't have to be Mingo. I could call this Sean or data. Just a variable name. And later on, we can do operations to it. So you'll notice in RStudio, and this is why this is such a great place for writing R, up here in the environment, we've got a list of our all the data we've uploaded. In this case, we just have one, which is called Mingo. Okay, so what is this? 37154 OBS of 42 variables. This is a fancy, sciencey way of saying 37,154 rows, and there are 42 columns of data. Instead of rows and columns, in R and RStudio, it's observations and variables. Just know that's what we're talking about it. Okay, so there it is. So you may be asking yourself, how do I look at this data? So let's start exploring it. The easiest way is to just come over here to the environment viewer and double click on the word Mingo in our environment window at the right. And it's going to pop up a spreadsheet for us to explore. All right. All right, there it is, right? There's all 42 columns. As I scroll down, I can see all the way to the very bottom. So 37,154 rows, 42 columns. To go back to my file, I can just click over here. I can also close this. Okay, so I can also, instead of double clicking to see it, I can also write some code to allow for that. So inside of this code block here, right, I have this function called view. There's a capital V. Instead of most functions start lowercase, I think that's because it's like an RStudio only function. It's not part of R. It's like a thing that only works in RStudio. I may be wrong about that, but I'm pretty sure that's correct. If I press play and run this, the same thing happens, right? This spreadsheet, in R, this is often called a data frame. In the tidyverse, they refer to these, like a version of these, as tibbles for some reason. Yeah, so we can look at it here. That's one way we can get a sense of it. Within the spreadsheet, we can also sort, as we'll see, highest to lowest. We're going to get to filters later in this lab. There's also, you can turn on filters and just filter subsets of the data. As far as I know, and man, I really hope I'm wrong about this, but there's no way to freeze panes like you can. You can freeze the column, as you scroll down, the columns stay fixed, but there's no way to freeze the DEA number column as you scroll across. So it can be kind of hard to work with data in this format, but okay, so we can also get a sense of the data in a more concise way using the glimpse function. I find this to be particularly useful to examine for flaws. So I'm just going to run this and then we can look at it together. So notice when I ran this, it ran down here underneath. If I pop up the console, it also appears there. That's the usefulness for these R Markdown files. So I can look at these, and if I see a whole column full of nulls, maybe. So first let me say, what are we looking at here? So Glimpse gives us the number of observations, the number of variables. It's got one row for each column. So this is each of the 42 variables. It tells us in gray here, it tells us the column type. So CHR stands for character or text. It's a string of text. Notice that it's in quotes. You'll often see that with text data. Double DBL is a form of, it's a number. For example, the dosage unit, which is the number of pills, is stored as a double. When you read in the data, the reader package is going to make some assumptions about data. Sometimes it gets it right, sometimes it gets it wrong. It may put the wrong type. So this is a good way to see if something is stored in the wrong format or not. And then over here you have examples of the first like 15 to 20 values, say, or in some cases 2 to 3, depending on the length of the field. And this will maybe give you a little bit of a sense if there's some major problem with upload. We can also use something called the summary function, which I'm pretty sure is base R. Yeah, so I wrote out summary there and see it popped up base. So this isn't part of the tidyverse, but summary. So I'm saying summary Mingo. Remember, that's the name of the object. That's what I stored my data as. So summary Mingo, and it will produce this. So for all of our like text columns, all it says is here's the number of rows that we have, and it'll say character. For our numeric columns, so like dosage unit, right? It gives us some summary statistics, which I think is pretty useful just to get a sense of things, right? So the largest number of pills in one transaction is 24,000. The smallest is 20. The median is 500. The mean is 1,030. And then first quartile and third quartile, I think it's quartile, maybe quantile. It's either 20% or 25. And this is either 75% or 60%. Those are the values. So it gives you a sense of kind of the range. So yeah, those three things I kind of like to do just to get a sense of what I'm looking at. As I'm working with data later on, I'll often use the glimp function in case I can't remember the name of a column. So yeah. Okay. So this step here, if we'd identified some flaws, is where we would typically do some initial data cleaning. For the moment, we're not going to do any of that. We will do some lessons later in the semester on data cleaning. I cannot stress enough what a critical part of the job of a data journalist is to clean data and prepare it and get it in a format in which we can ask it questions that is not going to lead to some sort of flawed result. This data set, because it was processed by the Post, I've worked with it a bit. Now, it is pretty clean, and as a learning exercise, I think it's okay to proceed. Just know that, especially when we're working with new data sets that we got through a public records request or something, a lot of time is dedicated to cleaning before we can get to analysis, cleaning and checking. Some people say, for data analysis, it's like a 90 to 10 ratio for cleaning to analysis, 80-20 I sometimes hear. Either of those things is not like far off. So if this is something you sort of want to do for a living, you're going to have to develop an appetite for data cleaning. For now, so we don't scare you off, we're going to get to the data analysis. Okay. So as we learn R and the data journalism pipeline using the tidyverse, we're going to proceed through the basics and we're going to get to harder material. Many of the concepts we're going to learn today and in the next lab are not new to us. So in Google Sheets, right, we learn to ask and answer questions by sorting the data or ranking it or calculating summary statistics or counts and sums and averages. Calculating percentage of total. We built pivot tables. We're going to learn today to do a lot of those same things. Not all of them, but in the next lab we'll pick up from there. Okay, so as we saw, this data set we're working with is it's pretty wide. There's a lot of columns. Something you'll learn pretty quickly is that it's often easier to work with, many of, depending on what questions you want to ask of a given data set, not all of the columns are going to be like particularly useful. So the first thing we're going to learn from the tidyverse is a function called select. So like all the functions we've worked with, right? It's select and then parentheses, and we're going to put something in here in order to execute the function. So let's just go ahead and run this below, right? Select Mingo, buyer name, buyer city, and dosage unit. Remember, Mingo is the name of the data set that we're working with. So I just want to kind of show you what happens here. So normally, right, this data set has 42 columns, right? It's very, very wide. This function here, what we're doing is we're saying select Mingo. So this is the first argument or thing that we're feeding into our function. So the name of the data frame, that's Mingo. And then what we're saying is select only these three columns, the buyer name, and the buyer name is the name of the pharmacy. Remember, this also has manufacturer and distributor data in it. The buyer city and the number of pills. So each one of these three records represents one transaction. Okay, so just want to kind of go over this, right? So if you're in this data frame viewer in R, you can see all of the data, all of it. Sometimes if you're working with really huge data sets, it might load really slow, but this is not a particularly giant data set. I know Google Sheets kind of choked on it, but 37,000 records of 42 variables for R is not even a big deal. So we can look at all of it. When we're working this R Markdown file and we get the output of our function here in this little table, it is limited a bit. So it's returning these three columns, and each page has 1 through 10 of 37,000 rows. 2, 3, right? I can go all the way to 100. So it's really only printing out the first like 1,000 rows. What I'll generally say is if you're going to work with something that's like really huge, you're going to want to write a function to view it, and we'll walk through that in a second. I can print out more rows here. So here's that same function that we just ran, but instead of just having like tick 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 bracket R bracket, now I've got tick 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 bracket R and then a little property here which says print 2,000 rows. Okay, so let's run that and get ready to scroll because it printed out the first 2,000 rows, which it's a lot. And if the point of these files or to R Markdown files is really like to have something that you can present to somebody later on, and spitting out 2,000 rows like this is generally not something you're going to want to do. I can close this, by the way, by just hitting this check mark. So how can we write these in R Markdown, which is a format really for presentation, but still allow us to do exploratory data analysis as we're working to perfect these documents. What I like to do is we can sort of wrap what we're trying to achieve here, which is a slice of the data with just 3 columns, and then pop it up in view. So remember this view function, right, that allows us to look at this whole spreadsheet? Now I'm just putting select Mingo buyer name, buyer city, dosage unit inside of this view. And when I run it, it pops up. There's the name of the function up there. And here's a little more wieldy or not unwieldy version of my spreadsheet. So now when I scroll down, I've got like, all 37,000. I can look and explore. I can sort from highest to lowest if I wanted to do that. You may also find it helpful, and this is something we'll do as we sort of go on. There are times when it makes sense to do it and times when it doesn't. To take whatever functions you're using to produce a subset of the data and store it as a new object. So in this case, I've got this select Mingo buyer name, buyer city, dosage unit, the same function as before. And I am storing it as an object called Mingo Pharmacies. And then below, I wrote a little bit of code to view it, so that'll pop that up right in this viewer. And I can also print it into our code block below. So I'm going to run all three of those things and let's look what happens. Okay. So the first thing is, now I have a new object up here called Mingo Pharmacies. Same number of observations or rows, but instead of having 42 variables, I only have the 3 I selected. When I ran this view up here, it popped it up into a new sort of data frame viewer. And I can also print it in our R Markdown file below our code block. So that's it right here. Okay. So remember now we've got Mingo and Mingo Pharmacies. I just want to show you a little trick here. Let's say I wanted to take that away. It's good to keep a tidy workspace. If you're not going to use something, kind of get rid of it. If you're working with lots and lots of very large files, eventually the memory in the workplace will start to choke. Here's a new function for you called remove, or RM. So just RM and then Mingo Pharmacies. When I run that, it goes away. So that object was called Mingo Pharmacies, and I removed it. So it's gone. I'm going to take this opportunity to show you what an error looks like in R. So I'm trying to remove this thing called Mingo Pharmacies. I press the play button, and never mind. Did not get an error. We'll show you what an error looks like kind of later on. Okay. So a little more on select. So we can, affirmatively say what we want to select. So above we said select the buyer name, the buyer city, and the dosage unit. We can also use select to exclude certain columns and keep everything else. And we do that by putting a minus sign in front of the ones we don't want. So in this case, I'm creating a new object called Mingo Smaller. And I'm going to select from the Mingo data frame all columns except for reporter DEA number and reporter business act. So just want to show you something here real quick. I'm popping open the Mingo sheet. These first two columns are reporter DEA number and reporter business act, or what type of person is reporting. These are distributors. So when I run this, a couple things happen. So because I have this view function here, Mingo Smaller pops up. It also pops up over in my view environment. Now it's 37,154 rows of 40 variables or columns instead of 42, because I've taken these two away. And when we look at the spreadsheet, those first two things, reporter DEA number, reporter biz act, those are gone. Now we're starting with the third, what was the third column, or reporter name. We can also use select to reorder data, putting the most important things up front. So I've written some code below here, and you should be run it after I finish talking about it. We're going to select for each transaction. We want to do three things. So we want to put the name of the manufacturer first, which in our data set, the column is called combined labeler name. We want to put the name of the distributor, which is in our data set, the reporter name, and the name of the pharmacy, third, a buyer name. And that sort of represents the flow of drugs from manufacturer to distributor to buyer. That's generally how things are piped through in the system. And then we also want to put the dosage unit. And then we don't want to get rid of all the columns. We actually want to keep everything else. So we've put in this function called everything, and that puts all the columns at the end. So let's see what I got here. I'm creating an object called Mingo Rearranged. Select function, Mingo, combined labeler name, reporter name, buyer name, dosage unit, and then everything else. So let's take a look at it. Okay. So because I wrote this little view command function, it popped up here. It's called Mingo Rearranged. we can see over here that it's got the same number of rows and it has 42 variables. We haven't removed any variables or anything. All we've done is reorder them in the order we said. So labeler, which is manufacturer, to the reporter, which is the distributor, to the buyer, which is the pharmacy, the dosage unit, and then all of our other columns. So in case we want to go look at it, it's still there. Okay, there's a ton more we can do with select, and we're going to be going through some of those things as the class goes on. This includes renaming columns to make them easier to work with, selecting only columns that match certain patterns. If you want to see more on select, click that link, and select is from dplyr, which is a package within the tidyverse, and it will tell you, how to select columns to start with certain things or end with certain things, how to rename columns. Some really useful information in there. Okay, so to end this particular section, before we moved on to sorting, you have a task I want you to work through. So I want you to create a code block below. Remember, it starts with 3 tick marks, bracket R bracket, ends with 3 tick marks. And within that, I want you to write some code. You can use what I wrote above to select only those columns that relate to the pharmacy involved in each transaction. So there's a bunch of columns that relate to buyer, so buyer name, buyer DEA, buyer bus act, buyer additional call info, buyer address. So I want you to take only those columns that relate to the buyer, and then at the end put the dosage unit. I want you to store it as an object called Mingo Pharmacy and write a function to view it and another function to print it below the code block in our R Markdown file, and include some comments like I've done in all examples, so that we know what we're looking at there. Okay, so let's move on to sorting. So there are 2 main ways to sort. We can pull up our spreadsheet and click on the column headers to sort highest to lowest. So I'm just going to go ahead and run this code, and that's going to pop up our Mingo spreadsheet in the viewer. And so let's say I wanted to sort by lowest to highest or highest to lowest dosage unit. I just click here. So that's lowest to highest. This is the number of pills in a given transaction. All right, to highest 24,000. I can also sort character columns alphabetically. So this will sort from A to Z for the name of the company distributing pills. Okay. It's better though, I would say, generally speaking, when you're exploring data, it's okay to just kind of sort through stuff. But part of the point of using our Markdown files and making our process as transparent and reproducible as possible, we want to write code to do it. So it's good to learn the functions. So the function here is called arrange. It's not called sort. And the function itself takes 2 arguments, or things we're putting into the function. The first is the name of the data set. So in this case here, right, it's Mingo. So what I'm saying is arrange the Mingo data set by dosage unit. And by default, it sorts lowest to highest. I'm going to start commenting out this view function, and we'll just look at how it's like printing out in the console below. If you want to explore all the data, you can uncomment this and run it, and it'll do the same thing. And I know it's only returning a subset, but for now, this will allow us to see the sort of top values. So when I hit play, remember, it's created an object that is stored as Mingo sorted low high, and I've arranged the dosage unit, arranged the data set Mingo by dosage unit from low to high. So if I scroll over here, see the dosage unit, we have the smallest ones at the top, 20, 30, all the way up to 100. If we kept going, there's one in there that's like 24,000. We can also sort highest to lowest by wrapping the column we want to sort inside of another function called DESC, and DESC is short for descending, which is sorting from highest to lowest. So remember, by default, the arrange function sorts from lowest to highest. We're going to override that with DESC. So remember, I am again storing the sorted spreadsheet as a data set called Mingo sorted high to low. And when I print that, it's created a new thing up here in our environment, a new data set. And then when I scroll to the right now, when I look at dosage unit, now it's got all the big ones at the top, 24,000, 17,5. When we get to the 1,000th record, it's still at 6,000. You can read more about the arrange function here. Sorting is a really basic thing, but really useful when it comes to making sense of your data. Okay, so I want to talk now about how we combine different kinds of operations. So far we've learned how to select certain columns. We've also learned how to sort. And in our last example, you could see that it was like pretty unwieldy to go actually find that we had sorted by dosage unit from the highest to lowest, because that dosage unit column was so far over, right? I had to like click all the way across until I finally got to the dosage unit field, and it's hard to see which pharmacy it applies to. So it would have been useful to first select only a handful of columns, then do the sort. So I want to show one way we could do that, right? So we could take this function for selecting from the Mingo database only the name of the labeler, right, which is the manufacturer, the reporter, which is the name of the distributor, the buyer, which is the name of the pharmacy, and the dosage unit. So I could take that and store it as this thing called Mingo rearranged. All right. And then I could arrange our newly created 4-column data set called Mingo rearranged and sort it by dosage unit from highest to lowest descending, right? So I'm calling this Mingo rearranged sorted. And then I'm going to print it out in the console below. So what do we get here when I combine those three things? Well, I get a smaller sheet with 4 columns, and now it's sorted from highest to lowest. Okay, that is a lot more work than we need to be doing, and especially as you see later on when we're trying to chain together lots and lots of functions, what we'll find is that we'll have to rewrite this a bunch of times, rename things a bunch of times, and the problem with that is that every time we're rewriting something, it's not that it's like, a lot of times computer programmers will say like don't rewrite anything or don't repeat yourself because it's inefficient. I care less about that. The reason I care about writing the smallest amount possible is every time you have to rewrite something, you're introducing the possibility you're going to screw something up or make an error. So while a lot of programmers are concerned about efficiency, I'm slightly less concerned about that, and I'm more concerned about, as a data journalist, accuracy. So luckily, the Tidyverse makes possible this really great way of sort of chaining together functions into one sort of one group of operations. And in the Tidyverse, we do this with a thing called a pipe, and this is the pipe symbol here. So it's percent greater than sign and then percent. Another way that I and others have said to think about this is that the pipe represents a phrase meaning and then. Do this, and then do this, and then do this. So the code below here is basically exactly the same, like it's the same output as what we have in this block up here. It just does it in fewer steps. So I'm just going to run it, and you can see that it does indeed spit that same thing out. And then I want to break down what we're looking at here. So again, we're creating an object called Mingo rearrange sorted, which was like the last thing we created in the code block above. And then here we're storing it as an object again. And then here we're putting the name of the data frame we want to do all our operations to. And then we have a pipe. So what I'm saying here is take this data frame and then select the following columns and then arrange them in order from highest to lowest by dosage unit. There's a key difference here in this chain of functions and the thing we just wrote above, which is in the thing above, each time we did this like select statement or arrange, we had to put the name of the data frame we wanted to do the operation to. When we start using pipes, we don't have to. We just put the name of the thing we're doing an operation to, the data frame we're doing an operation to, in this case Mingo. We're putting it up top here. And then we're saying all of the functions that come after it, we're doing it to that data frame. So we don't have to rewrite it here over and over again. It's more efficient, prevents errors. And we can keep adding different functions here ad nauseum. We can add in filters, as we'll see, and group by things and summarize to create pivot type tables. This is get really used to using these pipes because that's the way we're going to do it in this class. Okay, so you have another task here. So down here, you're going to create another code block. And in the code block below, I want you to use pipes to create a chain that takes the Mingo data frame, right? This Mingo data frame here, and select all the columns related to the pharmacy that's involved in each transaction. So we just did some version of this above, right? The name, the address, the state, the zip code, that sort of thing, right? And then you're going to sort it lowest to highest by dosage unit. You're going to store it as an object called Mingo Pharmacy. You're going to write one function to view it and write another function to print it in our markdown file, and you're going to include comments. So the thing you're going to produce is going to look a lot like this, right? You're still going to have Mingo at the top of your statement and a pipe, but what we're selecting is different here, right? We're selecting all of the columns related to the pharmacy and the dosage unit, and then we're going to arrange them. And the name of the object is going to be different. But I want you to get some practice with writing these pipes. Okay, let's move on to filtering. So we did some filtering inside of Google Sheets. There are two main ways of filtering within RStudio. So if you're exploring, you can also filter directly within RStudio's data frame viewer. I'll go ahead and explain how to do that now. So you've got this Mingo data sheet up with 37,000 observations. I'm just going to click this button that says filter. And in this case, I want to filter for the largest transactions. So I'm going to click into dosage unit here. So I want the transactions with the highest number of pills. And notice it brings up this kind of histogram. This is a little bar chart basically showing like how the different numbers of pills in each transaction are distributed. I'm just going to type 12,000 to 24,000. And so what this does is it filters only for those transactions where the number of pills was 12,000 or above. You can also sort this so we can see the highest one is 24,000, the lowest one is 12,000. Okay. Again, that's fine for exploring. The problem with that is it doesn't allow us to keep a record of our work. and a thing, again, we always want to do here is to get in the habit of writing code that we can refer back to later, that others can look at, that we can check. In the code example below, we're going to basically take the last thing we created, and we're just going to add a filter to it. So again, we are taking the data frame Mingo, right? And we're storing what we're doing as an object here. So first we're selecting 4 columns. The name of the labeler, which is the manufacturer, the reporter, which is the name of the distributor, and the buyer, which is the name of the pharmacy, and then the number of dosage unit. We're sorting by dosage unit from highest to lowest. This DESC means highest to lowest. And now we get a new thing, right? So we throw a new pipe on the end, and now we're filtering, and we only want those cases where the dosage unit is greater than or equal to 12,000. This is how you do greater than or equal to. So I'm going to hit play. All right. So now we have a much smaller subset of our data here. So in this table that pops up, we've got 25 rows and 4 columns. And if I want to page through to the next 10 records and the next 10 records, I just hit these previous and next buttons, or hit the numbers themselves. So you can see, right, this is only the 24,000 is the highest, 12,000 is the lowest, so we've successfully filtered. The other thing to say is we've been in the habit of, as we've gone through this exercise, a lot of what we've done is store each query as a new object so we could pop it up in the viewer and look at it. And I think this is a good idea or a good habit to be in if you are writing a function that's going to produce like a really giant slice of data. But if we're working with something smaller, we really don't need to do the store it as a separate object and then view it. Ultimately, saving lots and lots of separate objects will eventually start to eat up our memory and slow down our computer. And it's not really necessary. I mean, this last one, right, it's only 25 rows of 4 columns. That's of a very manageable size that I can look at inside of this, the data frame that pops up inside of the R Markdown file. And so if I just want to do that, if all I want to do is look at it inside the R Markdown file, I don't need to store it as a separate object. So in this next code block below, what I have here is I've just copied the function part from the previous one and pasted it in down here. Okay, so what do we have here? It starts with Mingo. It's the name of the data frame. So take Mingo, data frame, and then select the 4 columns we want, and then sort from highest to lowest, and then limit it so we're just getting only the 12,000 records. And then when I run that, I don't need to put in like print or view or anything. It just spits out right there. So generally speaking, if you're working with smaller stuff, this is what you're going to want to be working in. So we don't have to just do one filter. We can do multiple filters. So I want to show you how we apply 2 at once. So this basically says, this bit of code below says, again, take Mingo, select only the 4 columns we want, sort them from highest to lowest, filter only for the 12,000 pill transactions or higher. In this case, I've used comma to say and, right? And only return the transactions from this Actavis Pharma Inc., right? So this one above gave me Actavis and Spec and PAR. I really only want Actavis. So when I hit run, now I've got only the transactions from Actavis that were above 12,000. Okay. Another thing to point out too, right? So I just showed you that we could filter by 2 columns. We can also sort by more than one column. So this code block here that you see is exactly the same as the one above, but in this case I've added two more columns to sort by. In addition, after sorting by dosage unit, then we sort alphabetical by reporter name, that's the name of the distributor, and then buyer name, name of the pharmacy. So when I run that, we see I've sorted by dosage unit. These are all Actavis Pharma Inc., right? These are all Actavis Pharma transactions. And then I've sorted by the reporter name and the pharmacy name after that, alphabetically. Okay, so in the above example, we're filtering by two things. We're essentially saying filter by this thing and this thing. And that's, again, is what the comma inside of our filter function does. It means do this and this. We can also filter by one thing or another thing. So the code example below that you see here is exactly the same as above, but we're adding one twist. In addition to the filters for dosage units above 12,000 from Actavis Pharma, I'm also adding in kind of an and or. So what I'm saying is show me the dosage units above 12,000, show me only shipments from Actavis, and show me only those cases where the buyer was Stroh-Snyder or Riverside Pharmacy. And notice that I have that or statement inside of parentheses. And this pipe here, this is called a pipe, which is confusing because these are called pipes. But this is a pipe. It says or this. So when I run it, let's take a look at what we get, right? So above, I got a bunch of records that were for Stroh-Snyder or Riverside Pharmacy or Tug Valley. But now I've limited to say only give me back where the pharmacy is Stroh-Snyder or Riverside. In that case, I get 10 records. Tug Valley has been eliminated. We can also filter without needing like an exact match. So all of these things were the complete name of the labeler or the pharmacy, the manufacturer of the pharmacy. We can filter without needing an exact match by using the string detect function. So the following code here is the exact same as the block above, right? So I want only the biggest dosage units over 12,000 from Actavis Pharma, which is the name of the manufacturer, that were sent to Stroh-Snyder or Riverside Pharmacy. And in this case, I'm really interested in looking only at shipments from a distributor called Miami Lucan. And in this case, it's instead of searching just for Miami Lucan, I'm going to use this string detect function to search for cases where the word Miami appears anywhere in the name of the distributor. So this function takes two arguments: the column that I'm looking for and the phrase or the string that I'm looking for inside of that column. So when I run that, it gives me back only the shipments from Miami Lucan. Now remember, above here we had McKesson and AmerisourceBergen, but here, even though I didn't feed it the full name, Miami Lucan, I was able to pick out those because I used string detect to search for Miami. So string detect is from a very handy package that's part of the Tidyverse called Stringer. Its icon's pretty cool. It's a little violin. It's a good R joke because it has strings. And Stringer is all about working with text data or strings of characters, and allows you to manipulate a lot of character-based data. Okay, so your task now is I want you to figure out how to modify the filter below the one I've got here in this code block, so that it returns only the 3 records for H.D. Smith Wholesale Drug. So right now, when I run this code, it returns 4 records. It returns H.D. Smith Wholesale Drug as the distributor. So again, this is only looking at big shipments, dosage unit. And I use string detect to pick out all of the distributors that had drug in their name. Maybe I've gotten a tip from a source that there was a big shipment from a company that was like something Drug Corp or Wholesale Drug. You're not sure exactly. Okay, so by putting in string detect as drug, it returns H.D. Smith Wholesale Drug, H.D. Smith Wholesale Drug, AmerisourceBergen Drug Corp, H.D. Smith Wholesale Drug. Okay, so here's what I want you to do. I want you to modify what's in here, inside the quotes, inside the string detect function, so that it only returns the 3 records for H.D. Smith Wholesale Drug, H.D. Smith Wholesale Drug, H.D. Smith Wholesale Drug. Does not return AmerisourceBergen Drug Corp. Okay, so here's one way you could easily do that, right? You could take the whole name of that organization and run it. Let's try that again. Okay, so we could take that whole name and run it, and it would spit it out. But that's not what I want you to do. I want you to find a way to tell R to filter out all of the cases where drug appears at the very end of a company's name and ignores when drug appears in the middle of the name. That's what I need you to figure out how to do. Okay, so why are we doing this? My guess is you have no idea how to do this, and that's good, because a big part of being a good data journalist is that often we'll have something we want to do, and we'll have a vague idea that it's possible to do that with code, but not know exactly how to do it. And the key skill we're trying to develop here is, how do we take this like vague idea of what it is we want to do, translate that into whatever terms we can think about it, like find drug at the end, and create a way to search for that answer. So maybe we're thinking, how I might type like how to filter words at end of name R stringer into Google. Or maybe we ask a friend, or maybe we post about it on Stack Overflow, or we go look in the documentation for the package that we're using. All right. So again, what I want you to do is figure out how you might modify this so that it returns only the word drug. It returns records only where the word drug appears at the end, but not in the middle. So here's a hint for you. You can do it by putting one character at the end of the word drug. So this isn't the character, but let's say we put a question mark there, right? What I'm looking for is one character that will solve that problem. I'm not going to tell you how to do it. I want you to start understanding that part of this process is going out and figuring out how to do it on your own. So I'll frequently throw in challenges like this as we're going through. Today I'm going to help you out a little bit. Here is the documentation page for the stringer package, which talks about something called regular expressions. And somewhere on this page is the answer for this question. Maybe not exactly, but there's information that will allow you to figure out how to do it. Take your best step. You don't need to create a new code block, just modify the code block so I can see it. Okay, so once we're all done working in our R Markdown file, we can produce a nice little web page that includes all of the text we wrote, all of our code, and all of our outputs. This assumes that there's not some errors in the document that will prevent us from doing it. Oh, I was going to show you what an error looks like. So let me just show you a quick example like that. So there is no function called prin. There is a function called print. But let's say I mistyped print and just wrote prin, and what I'm seeking to do is print out my name. And I press the play button, and we get an error. So really handy. First, pops up in red here, something's gone wrong. And then error in prin, could not find function prin. So here's a thing I'll often do. This one is pretty obvious why this happened, but for me, but maybe for you, you're not sure why this occurred. A thing I will often do is just take the error message and search it. All right, so here's some potential answers. Error occurs when a package has not been loaded into an R library, so that's a reason. Could not find function base R, maybe I'll search that. Okay, so here's Stack Overflow, which is a great site, right? So somebody posted a question. I'm using R and tried some function, but I got the following error message. Error, could not find function, some function. This question comes up regularly. When you get this type of error, how can you solve it? And oh look, a ton of people have put in answers, and this one's been uploaded 114 times, and here's a bunch of things to check. Here's the first one. Did you write the name of your function correctly? Oh, all right, so I'm gonna go back to R. Oh, no, I didn't. I meant print, and I wrote prin. So there's print, and I run it, and it works fine. Okay, so I guarantee you're going to run into a lot of errors as we go through this, so something to keep in mind. Okay, so once we're all done working in our R Markdown file, this is the thing we're going to turn in for homework, so you're going to upload this to Elms, but the other thing we can do is produce a nice little web page that includes all of the text we wrote, all of our code, and all of our outputs. It's pretty great. I mean, these are the kind of things that you'll show to an editor or link to from your story or have somebody fact check. So I just want to walk through how to do it. So I'm going to click on this button that says knit up here. So knit the current document. And there's some options here. So I can knit to PDF. I can output this as like a PDF doc. Or I can knit to HTML. So I'm going to do that. And in the console, it's doing a bunch of stuff. And I'm getting some errors. Okay, so I got some errors when I tried to print that out, to load it out to HTML. So the thing that was causing a lot of the problems was that I had left uncommented out a lot anytime we tried to view a file. So before you export to HTML, and this generally won't be a problem in the future, but just something to sort of think about. Anytime we have view in one of our code blocks, just go ahead and put a comment in front of it, and that will solve the problem. Otherwise, you'll probably get errors when you try to output. Okay, so I've done that here, and I'm going to go ahead and hit my knit button again. So knit to HTML, and it's doing the whole build thing, and out pops up a nice little HTML document that includes a little table of contents over here that I can jump around. It's got where I loaded the packages, so my code blocks here, reading in the data. Commented that out, so because there is no view within the HTML document. Here's my glimpse. So we got our code and our output, code and output, code and output, code and output. Same thing, right? Yeah. So we'll go through more how to like prettify these and as we go through. But this is what you're ultimately going to submit for homework along with your R Markdown file. And notice it's over here on the left. Okay, I think that about does it for the video. So again, remember your assignment is to upload the R Markdown file and the R HTML, Intro to R HTML file to Elms.